As we've talked before, in order to make this graph, R must be making several assumptions about how we want this graph to look. It has to decide where to put the axes, how to scale the axes, how to label the axes, all of those things. So it's using what information it has to try to make some assumptions about what we want to do. So the information we're giving it are these variable names or the elements of a given list. And it can also figure out what the range of the values are for those variables based on the vectors that are in these variables. So it can figure out from that, and it can make some assumptions about where we want the plot to be and make a graph for us. But if we really want to take over how that works and be a little bit more creative about exactly where everything is on this graph, then we have to learn a little bit more about how graphics engines work and how to use R functions to control that. So if we go back to R, we're going to start breaking down what plot does instead of just using plot. Plot is actually a high-level graphing function, and there's a lot of things that you can do with it. However, plot is calling its own functions in order to do what it's doing, and we can call those functions as well and go through it in order. Now, the first thing we might want to do if we look at this graph is recognize that we've got all of this extra white space at the top. And that's because by default, it leaves space for a title for a graph. And if we don't really want to put a title on a graph, maybe we don't want all of that space. So the first thing to understand about a graphics engine is how you set up the canvas and how you set up the coordinate system for that canvas. Ultimately, if you're going to tell the graphics engine where you want to put something, you need some sort of coordinates to say, here's where I want to put it. Now, in this case, the coordinate system is based on data. And it's decided that it wants to put the edges of the axes where they are, and then it sets up a coordinate system based on 0, 0 being right here, and defining where the rest of the coordinate system that goes all the way to the edge of the canvas based on the highest value of our data in both the X and Y direction, and where that lines up with the edge of this plotting area at the top. So the highest time we have is 50. The highest concentration we have is 50. The highest time we have is 60. So it's putting those near the edge of the graph in terms of the coordinate system, so that if we put something at 0, 50, it's going to be here. If we put something at 60, 0, it's going to be over here in this corner. And these coordinate systems don't stop here at the edges of this graph. They actually go all the way to the edges of the canvas. So in R, the way that you establish the coordinate system is you tell it where the what the coordinates are that line up with the edges of this graphing area. So the first thing that you need to do is define this graphing area. And the way you do that in R is you tell it how far from the edges of the canvas you want these edges of the graphing area to be. So if we go back to R, the way that you control the edges of the canvas is with a function called par. And par is a generic function for accessing the graphing parameters. So par is just short for parameters, and it means graphing parameters. Now you can look at how all of the graphing parameters are set simply by calling par without any arguments. So I'm going to do that here down in the console. And you can see there's all of these cryptic things. By the way, this is a list. And there's a cryptic set of names for the elements of this list, like MEX, MAI, things like that, that tell you something about how graphs should be drawn. Now there's two different arguments to par that we can use in order to change where the edges of the graphing area are. And that's either this one, this MAI, or this other one, MAR. And which one we use depends on which units we want to use. Now in our case, we've been talking about the size of the canvas as inches, so maybe it's easiest to start with thinking about this as MAI. And this is how far from the edge of each side of the canvas we want to put the graphing area. And in our graphing, generally speaking, when you have 4 elements of a vector like this, they correspond to the bottom, left, top, and right edges of the graph. So this is 0.998 inches from the the graphing area is located 0.99 inches from the bottom of the canvas. It's located 0.80 inches from the left side of the canvas, 0.80 inches down from the top of the canvas, and 0.41 inches from the right side of the canvas. So hopefully that makes sense when you look at this graph. We're talking about this being the bottom, this being the left, this being the top, and this being the right. Now we can change that. So if we want to change that, we can use the par function to make changes to different arguments. And remember, it's a list. So if we want to specify a particular list element and change it, in this case, we can use the par function with the name of the list element we want to change. In this case, it's MAI. And we want to change it to some new value. In this case, we need 4 values. We're starting with these values here, and we need to change them to what we want them to be. So I'm going to simplify this a little bit because 0.997, well, that might as well be 1, right? So I'm going to call that 1 inch up from the bottom. I've got 0.8. I don't want to change that one. That one's in an okay spot. 0.8 inches from the left. That's where this is right now. And it's this top one I want to change. This one is what's too big. So right now it's saying that the top one is at 0.8 inches. Let's take that down to 0.2 inches. So we're changing this one from 0.802 to 0.2. And finally, the one on the right, let's look at that one. We can also make that one a little bit smaller. Maybe if we want to be consistent, we can make that the same as the top. So basically, this is how we're telling R that we want to move those edges in and change where the edges of our graphing area is, which inherently then changes the coordinate system for the whole canvas. So we can look at how that works by going ahead and running this code. And then, by the way, I'm using this Sumatra PDF reader. One of the nice things about Sumatra is I don't have to close it. It actually automatically detects when the file changes and refreshes the video or refreshes the image. That's not something you could do if you're using Adobe's PDF reader. So that's why I like using the Sumatra PDF reader. And you can see it's automatically updated based on the change to the PDF file in my product directory. And now you can see there's much less space at the top and at the right. So that is the first thing you need to do to take control over the coordinate system of your canvas to make it so that you can create a graph that looks exactly how you want it to look.